Hi there. Thanks for joining us. This is Space Nuts. My name is Andrew Dunkley, your host. Great to have your company yet again for this episode 358, or is it 35.8? Can't tell by my writing. Coming up, we're going to be looking again at Planet 9. There's some new information that's come forward that might actually point to the possibility of it really existing. We'll investigate that. And I don't think too many people in the world have not heard about the Titan submersible disaster. Well, there are lessons in that for the space tourism industry, which we'll also be discussing. And we will answer some audience questions. We've got a question that came in anonymously about emission spectra, but it's a really interesting question. Roger wants to explore comets, and Johnny says the Big Bang and the size of the universe don't add up. Please explain. We'll do all that today on this edition of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining me, as he does occasionally, is Professor Fred Watson, astronomer at large. Hello, Fred.
It's always a happy occasion when I turn up on Space Nuts. Thank you, Andrew.
Yeah, I makes me happy. Otherwise, I'd be sitting here going, what are we going to do now? What are we going to do now? Yeah. How are things?
Okay.
You got a new toy.
I do. In fact, 2 new toys. The one I'm staring at the moment is the new computer, which is up and running, at least as far as Space Nuts is concerned. There's still a lot of hard work to do to lick it into shape, but it is.
Yes.
It's fabulous. Like most scientists, I'm a Mac user, and so without advertising anything, I'm delighted to say it's a new MacBook.
Oh, very good. All right. And did I see a little note about you having a new member of the family?
There is, yes, another toy. We've got a minute to go and...
Yeah, sure. Why not? I mean, he's got to leave the building. Okay. This is intriguing to me. So I don't know exactly what he's got, but I know there's been a recent addition with the cat, although that might be a year or two down the track now. But, hello. What have we got here? Oh, my gosh.
Yeah.
It's a puppy.
It's a puppy.
Is that a little poodle?
It's a toy poodle, yeah. That's
Toy poodle.
Who is 9 weeks old.
Oh.
And I'm absolutely not a dog person, Andrew. I never wanted a dog, never thought I'd have a dog. But this little guy won my heart.
Now, Hugh has suggested you need to come up with a very Space Nuts related name.
Well, he's already got a name. He's more connected with my ancestry. So he's coal black, and he's named after the Geordie miners of northeastern England who are coloured. So his name's Geordie.
Geordie. Oh, I like it. Yes.
On his medal as well.
He looks a bit bashful at the moment.
He's at the moment. I think he's just fallen asleep actually. And
okay. Well, now you're stuck with him for the next 40 minutes while
he's going to go back very quickly. Well, he did sit on my knee for an entire hour-long Teams meeting yesterday with colleagues in the department.
Right. Until he peed. But yeah.
He does all that. As you know, we've had a bereavement in our family, and so this little fellow, we've got a breed of dogs in Australia called blue heelers.
We do.
This one is a black heeler, and heeler is spelt differently in that.
Of course. Yeah. Okay. Yeah. It'll help.
Yeah,
it will help.
Very so. I'm going to take him back because he's
okay. All right. I'll sit here and do what I do best, which is nothing. And how cute. So we've got Muskat somewhere prowling around. I wonder how Muskat is taking to the new arrival. I can imagine there might not be much love lost between the two of them for a little while, but time will tell, I imagine. Yeah, dogs and cats living together. What's the world coming to? I was just wondering how Muskat has reacted.
Sorry there too, Andrew. Muskat spent the last a bit longer than a weekend in hospital.
Oh,
He's
no.
very well. So this all happened while he was away in hospital. So he came back yesterday, and he noticed that there was something different in the household quite quickly. But they're going to be. I think they're going to be the best of friends. Actually,
Eventually.
I think they will eventually.
There'll be a few cat scratches on the dog's muzzle before that happens. I would think.
I don't know. The dog's pretty quick. Muskat's not.
He'll need to be. Yeah. All right. Oh, well, good for you. Now, let's get into this interesting story. Yeah, I think, we're here for some reason. We could start a dog podcast.
Your dog cast?
Yeah, it would be.
Yeah.
Oh, boom, boom. Bush tish for Fred. Let's get into this interesting story about Planet 9 and possibly some indications that it exists because of something else that has landed on Earth, apparently.
Yeah, that's quite right. That's that really, it's one of these things that I love, where you've got two quite different avenues of research, and suddenly they come together in a completely unexpected fashion. So, recapping on Planet 9, I think it was back in 2016. We've been talking about this really since the beginning of the podcast.
Yeah.
That it was noted that some of the what are called extreme TNOs, extreme trans-Neptunian objects, things that are way, way beyond the orbit of Neptune, maybe 10 times as far away as Pluto.
Yes.
At their extremities, because these all move in very elongated orbits. Many of those TNOs, extreme TNOs, have their orbits kind of aligned, all on one side of the solar system. So if you think of a map of the solar system, you've got the planets going around in circles in the middle, and on this scale they're invisible because we're talking about very big scales. And then you've got all these elliptical orbits of the trans-Neptunian objects, the extreme ones. And the sort of axes of these ellipses, the elongated long length of the orbit, they don't align exactly, but they're all clustered within an angle of probably 90 degrees or something. Some of them more closely aligned than others. Some, there's a group of them that are probably aligned with an angle of 5-10 degrees, something like that. And so it was that observation in 2016 or thereabouts that led astronomers. Is it Berkeley? I can't remember where these guys are. It's terrible. But the group of astronomers looked at this very carefully and deduced that it may be due to the perturbing influence of a planet at a much greater distance from the sun than any of the regular planets that we know about.
Yeah.
Estimated to be 4 to 10 times the mass of the Earth. So fitting actually rather neatly into a category of planets which we call super-Earths, which we find a lot of in other solar systems, in the exoplanet world, the extrasolar planet world. So that's the hypothesis that leads to the idea that there is a ninth planet in the solar system. And the problem now is finding it, because it's a long, long way away. As I said, like these trans-Neptunian objects, probably up to 10 times as far away from the sun as Pluto.
So finding something out there, because people are probably saying, look, if it's so big, why, we should have found it by now. But it's such a long way away. There's very little light. I think I read somewhere that it would be like using a microscope to find something you dropped in the sand or similar.
That's probably about right, because the place where it's sort of you can make a prediction of whereabouts in its orbit it's likely to be from how these other orbits are made, and the prediction suggests that it's kind of in the middle of the Milky Way. And so what you're trying to observe is an object in the Milky Way that looks like one of the stars in the Milky Way, but is moving incredibly slowly, because as objects get to their what's called their aphelion, the furthest point away from the sun, they move much more slowly than when they're at perihelion, the nearest point to the sun. That's one of Kepler's laws of planetary motion. Yeah. So it's kind of moving along so slowly that its motion will be barely noticeable. My guess is, we should put this on the record, that the Vera C. Rubin Telescope, when it starts its work, used to be called the LSST, the Large Synoptic Survey Telescope, will be doing surveys of the sky. It will be able to survey the entire sky to an unprecedented depth every 3 days, I think it is. It's incredible that it can do that. The entire southern sky, it's in the southern hemisphere.
Right.
So maybe, just maybe, because it will be looking for objects that are moving, maybe the Vera C. Rubin Telescope, when it kicks off, I think it's starting late next year, observations, maybe that will turn it up.
And the James Webb wouldn't be capable?
It's not the right telescope for doing that, because it's got a much narrower field of view. What you need to find this is a survey telescope, like our Schmidt telescope was at Siding Spring in the old photography days, where you're actually imaging a very large chunk of sky. It was 6 degrees on a side at the Schmidt telescope, and I think the Vera C. Rubin telescope, I think, I can't remember, it's 2 or 3 degrees, I think, its field of view, but that's what you need. The James Webb is focusing in on a really tiny area of the sky. So it's looking in detail at, particular objects. Now, the meanwhile is...
Yes, this is the interesting part.
So C-NEOS 14, and C-NEOS is something Near-Earth Asteroid Survey. I can't remember what the C stands for. This is an object which is actually a meteorite which fell into the Pacific back in 2014. And so 2 researchers at Harvard University have published quite recently a paper saying that this object, its trajectory when it entered the atmosphere, because it was observed, did not come from the solar system. So they're saying
an extra solar asteroid.
An extra solar asteroid, that's right, or an extra solar meteorite. It's probably, I don't know whether there's an estimate for how big this thing was. It is actually, the estimate is of the order of a meter. It's small, but its trajectory as it came into the Earth's atmosphere tells you that it hit the Earth at a very high speed. 60 kilometers per second is what they're suggesting, and that's typical of...
Geez, that'd put a dent in your Lamborghini.
It would, if it hadn't burned up and fallen into the Pacific. If your Lamborghini's in the middle of the Pacific, you're probably in trouble anyway.
Yeah, for sure.
Yeah. So this thing came from interstellar space. But what they looked at then was, okay, the alternative possibility that it's come from interstellar space is that it's flown by something in the solar system and had a gravity assist spacecraft. So it's got something, and its velocity has been bumped up to this 60 kilometers per second. And they did that. They looked at that because they could reconstruct its trajectory through the inner solar system, but they discovered that it didn't pass any of the known planets. So
so it didn't get an assist from Jupiter or Saturn.
That's
or
right.
Any of those.
That's right. But wait a minute.
Here we go. Here's the smoking gun.
Yeah, the smoking gun. What if it flew past Planet 9?
Yeah.
And so what they did was they looked at the sort of trajectory of this C-NEOS 14, the object that fell into the Pacific, and mapped it on the sky. And basically, it was exactly where we think Planet 9 might be. Not that we know where it is, but where, all the evidence suggests that it is. And the authors of this new paper suggest that is very likely. The probability that such a coincidence is the result of chance, as phys.org says, is of the order of 1%. So they're saying there's quite a high degree of certainty with the messenger, the object itself, that it rather than being an interstellar messenger, it's maybe something that's been in our solar system and has been whacked up to this very high velocity by an interaction with Planet 9 and came in at this angle and landed in the Pacific Ocean. So
It sounds really compelling, but it's not absolute proof positive. But
No,
gee, it would take some arguing against by the sound of it.
yeah, it's like many other things that you find in space. It's a very uncanny coincidence. There's coincidences everywhere in the universe. The biggest one being the fact that the moon's 400 times smaller than the sun and 400 times nearer, which is why we have eclipses, which is definitely uncanny.
So you can't write off a potential coincidence.
That's right. You can't write it off. In fact, this I've been reading, as I mentioned, this is on physics.org, but it actually is a piece that was on The Conversation by the authors actually of this work. So it's worth checking it out. Have a look for there could still be a ninth planet in our solar system on The Conversation.
Yeah. Now, what would happen next? Do they will people try to follow this up, or maybe the Vera Rubin Telescope will sort of take this theory and see if they can glean anything from it?
Yes, there is. So if you make the assumption that this object was deflected by Planet 9, and they suggest that would have been 30 to 60 years ago, then what you can do is, knowing the trajectory of the object, since we think it's come past Planet 9, that basically narrows down your estimate of where Planet 9 is in the sky now. It's sort of, rather than being a huge chunk of sky, it's kind of not far from the equator. It's where Aries, Taurus, and Cetus meet. That's what they're saying this object would be. So what they're doing now is carrying out a search in exactly that region where they've focused down from the C14 observations that's where this thing might be found. So if they find a moving object in there, it is, it's going to be a classic case of detective work of the highest order. I might quote a quick quote on what they say in their conversation piece. We have an observation campaign underway to carry out this search. The task is still difficult and it will take time and work because the field to be scanned is still large and the object sort is very dim, but it does now seem doable. And they go on to say, of course, today our hypothesis is no more than speculation, just like the existence of Planet 9 itself. However, it is a well-founded speculation that meets the three requirements to be taken seriously in science. A, it's physically plausible. B, it's well explained. And C, it's empirically variable. And that would be the case if they actually found it.
Yes.
Planet 9, indicated by the position of C14, where it came from.
Which stands for Centre for Near Earth Object Studies, by the way. Yeah. And being as big as they think Planet 9 might be, like, 10 times bigger than Earth, was it? Or something to that effect? It would have significant gravitational effect, I imagine.
Absolutely. That's right.
Yeah. Gosh, we're nearly there. I want to believe it. I really do. I hope they've found it. And we'll know soon enough, I suppose. This is, or not. Or not.
We'll know one day.
Yes, we will. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Okay, we checked all four systems and keying with a go.
Space Nuts.
Okay, Fred, let's move on to a rather somber topic, and that is a reflection on last week's terrible disaster involving the Titan submersible, which imploded while taking 5 people down to look at the Titanic. And it's been a terrible tragedy, but there are lessons to learn from it in regard to space tourism. And I must say, in reviewing some of the thoughts about the Titan disaster and the relationship to sending people into space, going underwater is not dissimilar to flying a spacecraft, because you've got to maneuver in 3 dimensions, up, down, left, right, backwards, forwards, whereas on the road, driving a car, one of those elements comes out because you're not flying or floating. So the similarities are quite significant. So are the dangers, as it turns out. And this is the lesson that needs to be learned, I think.
And indeed, that's right. The other similarity is, of course, you're in a tin capsule, if I can put it that way, which has got extraordinary pressures on its walls, and in fact, far more for the submersible than you would have on a spacecraft.
I think at its depth, it had like 400 G on it or something.
It's 480 atmospheres.
Atmospheres,
500 atmospheres. So that's the atmospheric pressure multiplied by 480. I think it was 480. Whereas that's all pressing inwards. Whereas in a spacecraft, you've got one atmosphere pressing outwards. So but the risk is the same in both. You're talking about any kind of breach in that capsule that you're in the enclosure, the envelope of the area that you're in. Any kind of breach is catastrophic, and more so in the case of the submersible.
And we may never know what triggered the implosion, but it was obviously it had to be a breach, a break in a seal, or just a pinhole or something. Some
of the analysis I read, because this submersible had made several trips, and was that it had an unusual composition for the capsule, which involved carbon fibers, and I think the comment by one of the engineers that I read said that every time it went down, those carbon fibers would be stressed, and yes, they'll do the job for a while, but eventually they'll give way, and that's the suggestion. That's
gosh,
really horrific.
Yeah. So what's the lesson for space tourism? Because this is a really, well, I'll put it in a way that people might understand, because this is how it's coming through in my mind. But space tourism, to a certain degree, is like the wild, wild west at the moment.
Well, it is and it isn't. It's, I mean, space generally, some people think it's like the Wild West with the advent of satellite constellations. But there are regulations. But what we're perhaps focusing on here, Andrew, is some comments by a very senior engineer who is Italian by birth, Tommaso Scoba. He is the executive director of something called the International Association for the Advancement of Space Safety, which tells it like it is. But he's also got a very strong track record from the European Space Agency. He was a former head of spaceflight safety at the European Space Agency, and so he was focused entirely on this issue. And what he's saying in a fairly lengthy piece that, again, was reported on space.com. It's actually by Teresa Pultarova. That's the name of the person who's written this piece, but it quotes Dr. Scoba, Tommaso Scoba, the engineer, very widely. And his point is exactly what you just said, the parallel between this infant industry of space tourism and the infant industry of submersible tourism, the Titanic exploration, that there are strong parallels. And the bottom line is you must not dodge the regulation or the regulatory framework.
Yeah.
So maybe I can just read a couple of the quotes that are in this particular article. There's a bit of noise going on outside, for which I apologize. I don't know what.
Oh, that's okay.
Yeah. And this is an organization called the Commercial Spaceflight Federation, and that represents the space tourism companies. Has not actually apparently commented yet on the possible implications of the Ocean Gate saga, the fact that this horrible accident happened. But there is an interview that's been recorded, and the Federation's president apparently argued very strongly against having a regulatory framework that would, that would give the tick of approval to the engineering of some of these spacecraft. And the argument was summarized by this paragraph, which I'll quote: "The vehicles that have been designed today are quite different from each other. And so if regulations had been written on any one style, that would really have prevented some of these designs from coming to the market." And that is absolutely true. When you look at Blue Origin with its sort of standard, firework rocket launch vehicle with a capsule on top, goes up, capsule detaches, goes up to 100 kilometers. You've got this weightlessness, come down on a parachute while the rocket launcher itself lands. That's quite different from Virgin Galactic's scenario, where you've got a space plane that is carried underneath the belly of a turbojet aircraft to about 16 kilometers and then launched as a rocket to take you up to the altitude at which you can see the Earth's curvature and the blackness of space and all of that. So that's true that these things are very different. But I think this is not necessarily a good reason for declaring yourself exempt from the requirement for certification. That's the bottom line. And perhaps I can quote this engineer, Tommaso Sgoba. He says the certification is essentially a peer review of your design by an expert. Instead of waiting for an accident, you perform your hazard analysis in advance. The solution to your hazard analysis is entirely in your design, and you get input from other people who understand this matter and that can help you make your product as safe as possible. Yeah. And so I guess he's aiming those comments at, well, perhaps Virgin Galactic, perhaps Blue Origin, but interestingly, not at SpaceX. That's because SpaceX has had the benefit of contracting to NASA, so it's had to fulfill all the regulations that the National Space Agency has in place. So SpaceX has essentially had to meet these requirements for its formal contracts with NASA. There's taxiing astronauts up and down to the International Space Station with the Crew Dragon capsules. It's had to do all that. And so now when it turns Crew Dragon into a tourist vehicle, and we've seen evidence of that recently, then you have all the regulations in place. But I might just add a postscript of my own to this, if I may, Andrew.
Sure.
And that is that because I don't want to be seen as being critical of any of these organizations, they are all working in good faith and doing their very best to make things as safe as possible. Scoba's point is that they should fall within a regulatory framework. But all that I've heard, particularly from the few astronauts that I've known well enough to talk to about this, they've all said, Virgin Galactic in particular, I don't have any comments on Blue Origin, and the situation might be identical with Blue Origin, but Virgin Galactic in particular has been very careful to follow the regulations, even though it is still sitting outside the certification process.
It's fascinating, and I suppose one of the things that I've read in regard to this is that back in 2004, US Congress issued a moratorium on regulations, which have been continuously extended, and I think they expire in October this year. And they may then decide, because of the Titan disaster, that the rules need to be tightened up. But as far as companies having to prove flight worthiness, all they have to prove is that they don't pose a risk to any of those people on Earth or airspace, and demonstrate that their space vehicles worked during one previous flight. I mean, that's a pretty thin,
it is, isn't it,
veil of safety. Yeah, if you really look into it. Yeah. And that, I guess, is one of the telling factors in this, that the FAA doesn't have much of a jurisdiction in terms of space tourism safety, and that's probably where things need to tighten up.
Yes, that's right. One indicator of how seriously Virgin Galactic in particular takes this is that they have had an accident. That was back in 2014 when
that's right.
one of their test pilots, the other one was injured. And that was actually human error that was shown to be. So that was 2014. When will be the first commercial fare-paying flight with Virgin Galactic? Well, it turns out, just by coincidence, Andrew, that it's tomorrow as we're recording this. 29th of June is the date that's been set for the first flight. It's actually Italian. I think it's Italian Air Force members, and I think it's a flight that will have scientific purpose as well. But it's, as I understand it, it is a paid flight, so it's the start of Virgin Galactic's tourist operations, fare-paying passengers. So yeah, it's. I think your point's well made that it's really interesting to see what will happen to the legislation and regulation in the wake of the Titan disaster.
Indeed, it will. All right. If you want to chase that story up, it's on space.com. Really fascinating read too, I might add. This is Space Nuts with Andrew Dunkley and Professor Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Okay, Fred, let's see if we can answer some questions. No, we can't. That's the end of the show. But we've got a few questions. One's a text question, and we'll get to that shortly. But I don't have a name attached to this question, but I'll fire it away. It's about emission spectra. This is a question without notice, Fred. Good luck.
Hello. What is the relationship between an emission spectra and black body radiation? If I heat up a lump of iron, that's like a black body, but why doesn't it just have an emission spectra? And if the sun is made of gas and plasma, why does it have a continuous spectra and not just an emission spectra? Thank you very much.
That's a curly one. So emission spectra versus black body radiation. Why is it so?
Why
By
is
the
it
famous
so? Yeah.
scientist.
Well, it's a great question, and I absolutely understand where that's coming from. And it's,
good, because I must confess it was a bit of a head scratcher for me.
So let's start with black body radiation. And by the way, spectra is the plural; it's spectrum for a singular. So the spectrum of a black body, and what we mean by that is exactly as the questioner says. If you get a lump of iron and heat it up at certain temperatures, it glows red. And if you look at that through a spectroscope, the device that shows you the band of colors ranging from violet up to red, short to long wavelengths, that band of colors actually, for a lump of iron that's red hot, it's a smooth curve. It's what a black body actually emits, and it has its peak in the red region of the spectrum. As you heat it up more, it gets white hot. And that peak shifts basically towards the middle of the spectrum and tends towards the blue when if you got the iron, of course it would melt and vaporize actually by the time you get to those temperatures, and wouldn't be a black body anymore. But that's the basis of black body radiation. So it is anything that is radiating purely by the energy that it contains, a solid object. And you and I emit black body radiation, which peaks at a wavelength of about 10 microns, which is well into the infrared region of the spectrum. And that's quite handy. That's not why we see each other, of course, unless you're looking through an infrared detector, in which case you would see our black body radiation.
Yeah.
We've got, just as an aside, we've got one of those in the dome at the Australian Telescope, several cameras pointing inside the dome so that you could see if somebody wandered into the dome in the middle of the night in darkness. Because that is a dangerous place to be, and you would want to know if somebody was wandering through. So when anybody goes into the dome at night, they look like this kind of sepulchric white figure wandering around. So that's black body radiation. Whereas emission spectra come from the excitation of individual atoms, basically. So as an atom gets excited, and there are many ways it can get excited, either by being heated or by electrical stimulation. If you have a spark or something like that, it will excite.
Or Australia winning the first test against England.
All of that would contribute. Yeah, that was pretty good, wasn't it?
That's pretty extraordinary. Amazing test match.
Yeah. So that and that means that you get light of a specific wavelength as the atom falls from a high energy state to a low energy state. So it falls from Australia winning to England winning the test match. But in doing that, it actually emits a photon of light, which has a specific wavelength. And that's why when you look at the spectrum of certain objects, the classic, which we could find easily, used to be sodium vapor street lights, low pressure sodium lights.
Yeah.
Go put one of those, you see this single orange line. It's actually two together, which is what you get when sodium atoms relax after being excited by electricity. So there's nothing else in the spectrum. That's why the street lighting, the old sodium vapor lights, were a bit weird in appearance because everything was being illuminated by one color. And it was very hard to have color distinction. And that's one reason why we don't have them anymore, because it's thought to be detrimental to safety if you can't see the color of things. So that's how emission lines work. Now the sun behaves like a black body. The photosphere, that's the hot surface of the sun, is simply radiating energy because it's hot. It's a bunch of atoms, but it's also a solid body and radiating as a solid body. But it's surrounded by an atmosphere, which we call the chromosphere. And that atmosphere has atoms in it which actually extract the light of the sun at the particular wavelengths that they would emit light if they were being excited. And so we get dark lines in the sun spectrum, which correspond to where the bright lines would be if you're looking at a single spectrum. So, for example, there's a pair of dark lines at the sodium wavelength, and they're called absorption lines. And that's where you've got a black body radiating a light at all wavelengths effectively, and individual wavelengths are subtracted from that by the atoms in a cooler gas surrounding it. These are Kirchhoff's laws of spectral observation. And I've just recited them in a very gobbledygook way, but I hope that helps our listener.
Indeed.
You have looked thoroughly baffled throughout that whole conversation there.
No, it is, to me it's complicated, but I'm sure to most people, that just makes sense. Yes, it does.
It's the stock in trade of how astronomy works. Ever since William Huggins and a colleague of his, whose name I can't remember, actually put a spectroscope onto stars back in the 1860s and heralded the birth of astrophysics, the physics of the stars.
Okay, fascinating. Thanks for the question. Sorry, we don't know who you are, but we appreciate you sending it in. We have a repeat offender coming our way now in the form of Roger.
Hey there, Space Nuts. My name is Roger. I'm a truck driver. I've called in a couple of times before, and tonight I'm traveling across Connecticut. I had a question about exploring the outer edges of our solar system. Now, we've sent out probes like the Voyagers that send back information, but they go out and keep on going. And I was thinking about something that could go out and come back. And I was wondering if we'd be able to catch a comet that's coming by and kind of piggyback a probe on it, either landed on it or more likely put something in orbit around it, where the comet could take it out and then bring it back. I understand this might be, hundreds of years of a voyage, but when it come back, we could retrieve it and get samples and information about the trip and what happens with the comet on the way. And I don't know if something like that's possible, or if you've heard of such a thing. But that's my question. And still listening to the show and loving it. And you guys keep on trucking.
I knew he was going to do that.
Oh, great stuff, Roger.
Oh, thank you, Roger. Lovely to hear from you again. And we've sort of done this a bit with intercepting asteroids and getting samples and bringing them back. Was it Ryugu?
That's right.
Yeah, but to actually piggyback a comet for its entire journey, that would be fascinating.
It's already been done, actually. When you
Has it?
Well, Churyumov-Gerasimenko, otherwise known as 67P, that comet which was visited on its inward journey to the Sun by the Rosetta spacecraft.
That's right.
Around it. And Rosetta, it's not quite the same as Roger's suggesting, because Rosetta crashed onto the comet.
It did.
Now being carried, and that was intentional to effectively end the mission. That's now been carried out to the depths of the solar system. The period of 67P is quite short. I think I can't remember how many years it is. I think it's 10 years or less, something like that. From my memory seems to think of 6 years being its period around the Sun. So it's not one of these comets that would have been originally a comet that fell in from the Oort cloud from the depths of the solar system and then got modified by perhaps passing close to Jupiter. It's possible. But the reason why it's not done is because you can do it a lot faster by sending out a probe whose speed you can control, and you're not just relying on hitchhiking a ride on a comet. So, for example, New Horizons got out to the orbit of Pluto in about 9 years. So that's much slower than your average comet would do it in. And so, yes, even like Comet Halley takes 76 years to go around once. So if you hit
6.45 years. 6.45 years for 67P.
Hey, not bad, eh? Since we've talked about 67P, it's still all in there somewhere. Anyway, that's right. So it's if you Comet Halley, if you wanted to see what it was like at its aphelion, the point furthest away from the Sun, which I think it's certainly beyond Jupiter, maybe beyond Saturn. That's going to take you 38 years to get there. Half the orbit period. Whereas, New Horizons sped past Pluto 9 years after it was launched, because we can give it that much higher impetus with rocket motors. So it's a lovely thought. And in a sense, as I said, Roger, you're right on the money, because it's already happening with Rosetta being carried out further out into the solar system. But there are better ways of doing it.
Yeah. Wasn't Rosetta a successful failure?
It was actually the one bit that failed was what was it called? The little lander, which has the name of an island, which I've actually visited because they had to move it in the Nile. That's all about the Nile. I can't remember the name at the moment. That's terrible. That has forsaken me. But that little lander actually landed successfully.
Philae,
that's right. But fell over.
Yes, that's right. I knew something happened.
Yeah, and it was in the shadow of a feature on the comet's surface, so it never got the sunlight that it would need to recharge its batteries. So that was the one thing that didn't work. But the probe itself was fantastically successful.
Yes.
And, I still see the images popping up on my screen from time to time that it took of the comet nucleus as it orbited around it. Fantastic stuff.
There you go, Roger. Already been done. Where were you? He was in his truck. He was busy. He was very busy.
Yeah. Keeping his eyes on the road. That's good. Well,
Yeah,
great.
But I don't doubt they'll do something like that again. They'll find a great target and send something up. And
well, yeah, that's right. And your point was well made that people intercept asteroids when they pass reasonably close to the Earth, and there's been Ryugu was Hayabusa 2's target. Hayabusa 1 visited comet an asteroid whose name I can't quite remember. That's terrible. It'll come back to me. And we've had also there's a NASA probe that's bringing asteroid samples back as well. So we do have ways of sampling these objects, but we tend to wait till they go past quite closely before we try and grab that.
Yes, indeed. All right. Thank you, Roger. We'll squeeze in one final question. Hi, I'm a long-time listener and thoroughly enjoy your wit and knowledge that permeates every show. I especially like the questions being answered, and as it happens, I have a question of my own. But we've run out of time, Johnny. No, maybe it's a dumb question, but I can't find the answer anywhere, and I'm sure it's only that I've missed something obvious. To my knowledge, everything started with the Big Bang, where the universe was created from a singularity, propelling all bits of the universe. And the age of the universe is supposed to be 13 billion years or so, 13.8, I think it is. But if nothing can travel faster than the speed of light, how can the universe be 97 or so billion light years wide? That is almost 4 times the speed of light for 13.8 billion years, assuming the Big Bang was in the center. From Johnny Hiard, I think his name is. Sorry if I didn't pronounce that properly. Thanks, Johnny. This is an old chestnut, I think, Fred. We get variations of this from time to time.
And it's a great question as well. And I guess it comes about because we are a bit sloppy with our terminology here. So the universe, we believe, is 13.8 billion years old. When we see the flash of the Big Bang, which we still can see because we can look back in time, we're looking back in time exactly as you've said, 13.8 billion years to when the universe was still glowing brightly. And so we see that as the cosmic microwave background radiation across the little sky, the cosmic wallpaper, as I tend to call it, because it's behind everything else.
Oh, I like that.
Yeah. Oh, good. Glad you do. Anyway, so that's got it's more accurate to say that horizon beyond which we can't see, and you can kind of regard as the edge of the visible universe because we can't see any more of it. We would say that is something we see at a look back time of 13.8 billion years because that's how long it's taken the light to get to us. Now, in that intervening time, the universe has expanded rather a lot, actually by a factor of about 1,300, if I remember rightly. It's more than 1,000. So the universe has expanded. And what that means is that horizon is now much, much further away from us in physical terms. And in fact, that 97, I think, is about right. It's something like 40 billion light years away in what we call proper coordinates. And by proper coordinates, I mean essentially the physical size of the universe. So yes, it's the distance of the horizon is something like 45 or thereabouts billion light years away, and that makes the observable universe as exactly as Johnny says, 97 or thereabouts billion light years wide. But we ignore that because we can't see that. We can never see the universe as a whole.
No.
All we can see is our looking back in time as we look out. And that's because the speed of light is basically the most important quantity in the universe in terms of our perception of it. And we're completely limited as to what we can see by the speed of light. So if we say, yes, the cosmic microwave background radiation is 13.8 billion light years away, that's kind of correct, but it's not correct either. It's far better to say it is at a look-back time of 13.8 billion years, because in reality, it's 45 or however many billion light years away it is because of the expansion of the universe.
Okay. I think you're right when you say that we've kind of cocked this up with the terminology we choose.
And it's not. I'm not talking about you and me. I'm talking about the whole astronomical community.
No, that's what I meant. It's like black matter, dark matter, and
which is another
dark energy, which is another mishmash of words that gives you a false indication.
Yeah.
So this is the same kind of thing. So short answer, Johnny, is that it's more a case of the terminology being inaccurate than the numbers being wrong.
Yeah, he's saying since nothing could travel faster than the speed of light, how can the universe?
How can it be?
Yeah, and it's just that the universe was much smaller when that light from the cosmic microwave background radiation left on its journey to us. And it's been expanding ever since. It's expanded throughout. And it's actually that expansion that has stretched the wavelength from visible light, as it would have been at the beginning, out to microwaves.
Okay, there you go, Johnny. Hope that doesn't give you a headache. But thanks for the question. It was a good one. If you would like to send us in some questions, please do. And you can do that via our website, spacenutspodcast.com or spacenuts.io, and just click on the AMA link or the Send Us Your Question tab on the right-hand side. If you've got a device with a microphone, it's as simple as just saying who you are, where you're from, and asking your question, and we'll do the rest. I'd like to send a shout-out to Steve and Tim, who are the hosts of Astronomy Daily. And don't forget to listen into that podcast with Steve and Hallie and Tim every week with updated information about astronomy and space science. They're good supporters of us, so I thought I'd better give them a shout out. And yeah, it's me brother. I've got to help my brother. Indeed. Thank you, Fred, as always. Great fun, and enjoy the new toys.
We are doing. Thank you very much. Good to talk to you, Andrew, and see you next time.
Okay. Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio for turning up today. And from me, Andrew Dunkley, it's been a great pleasure. We'll look forward to your company on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.